Welcome everybody to Geology 101. I will be your tour guide here, Professor Cedar, as we explore geology and Earth's formation. Okay, let's get started. So first things first, we'll be covering geology as a science. Here's what a normal person sees, and here's what the geologist sees. We'll cover this more in a bit. So first of all, what is geology? I ask this question every time as part of our first session in class, and I get these sorts of answers. Geology has to do with rocks, there might be the earth, talk about sediments, there's all these different processes and igneous rocks. It is all that, but first and foremost, I want the short answer here. What is geology? Geology is, in 3 words, study of Earth. Nice and simple, anyone can remember it. This includes not only the Earth itself, the rocks on it, but also things like oceans, glaciers, atmosphere, all of the life on the Earth and everything that goes on inside it. So let's take a look at a geologist here. This is Jack Schmidt, American scientist. He is either in Los Angeles, California, Hollywood area, or on the moon. I will leave it to you to decide which of those is more likely. And he's actually collecting rock specimens for laboratory analysis back on Earth. It is a true fact that a geologist is the only scientist who has ever set foot on the moon so far. Now, what is going on in this photo? What does this have to do with geology? This is a scientist, somebody from the University of Oregon, I believe, studying a volcano in Hawaii. This is actually part of their volcano listening project. Very, very interesting stuff. Have a link there if you want to know more. Part of the reason why I have included this is not because y'all didn't realize that a geologist can study volcanoes, but because I wanted to take this as an example of how powerful the scientific method can be. In a world where nobody knows what to believe, who's to say, who knows, it's all so complicated, this person knows, for a fact, knows with high enough confidence that she is going to risk her life on the knowledge that she is totally okay right here. Right? That level of certainty about gases coming out of a volcano, about conditions, about whether the volcano is likely to erupt, this is all gathered from scientific method. Now, here, it's very, very tempting to think this is geology because these are rocks. These are not rocks. These boulders are, in fact, alive. These are known as stromatolites. There are these clumped up algae mats, little layers of algae building on top of one another into these bigger structures. And these are actually very important because they last for a long time on Earth. You can find these things, these little boulders, which are hundreds of millions, even billions of years old. So let's go ahead and actually back up here for a moment. So all these people studying the Earth, why are they doing it? I've asked this question in class, sort of rephrased. Why is geology important? Root of it all is problem solving. Geology is one way of, let's get me out of the way, helping to understand important problems that go on in the world. Everything from minerals, metals, raw materials needed to produce everything that society needs, energy that we have to generate to keep the lights on in our homes, to keep people warm, feed the hungry mouths that have yet to come, everything from geopolitics to health to environmental issues to climate. All of these problems have either a small component or a major component in geology. So now, all the information presented so far is very, very practical, hands-on. We solve problems, we make the world a better place. But there's also this sort of bigger picture approach to it, the more poetic way of looking at it. Why do we study geology? What is the point of this science? Well, Earth is our home. It's my home, your home. The space billionaires, it is their home too. They're not wealthy enough to stay out there forever, thankfully. Earth is our home planet. We depend on it for all of our material resources. It goes without saying, but also, I have to say it. If we run out of some sort of resource on Earth, there's really not any other place that we can go to get it. What we have here is what we have. The natural world is very much worth saving and preserving. Because some of these resources are so limited, it requires people who know the Earth somewhat, understand the Earth somewhat, in order to thoughtfully manage these resources, make sure that they go to the right people who desire them most, value them most. And it's something that affects everybody. Changes in climate, as an example, are worldwide, might be localized in one point, worse in one place, better in another, but it still affects everybody on the planet. There really is no escaping from something like changes to the atmosphere. That one's going to affect everybody. Finally, human beings have a profound role in shaping Earth. As an example, biodiversity is going down, right? This is sort of the size of the domain which contains all life and all the different species, the amount of different, unique life forms out there. It's going down, and it's going down, no doubt about it, because of human activities. As part of appreciating our role in this, you might imagine sometime in the future where biodiversity has bounced back, and there's more life than ever before. Whatever world that is, the life forms on it would seem completely alien to us, because the life forms that were here whenever we came to power, right now, they're gone. They're not coming back. Anyway, back to the learning here. Geology as a science. Now, something we have to be very, very careful about. When I asked you guys about the scientific process, we did the murder mystery, we were going through, I asked the question to you guys, how is this science? This word came up a lot, theory, and it's useful, though, to talk about exactly what that word means, because it's not really the same word in scientific context as it is in normal life. You talk about a conspiracy theory, oh, I have a theory for how this happens, some theoretical how that happens. A theory in science is the highest level of knowing. This is the foremost thing that you could produce as a scientist, or that you, in a scientific body, collective, bunch of people, could produce, is a theory. It's some sort of testable, repeatable claim which involves an explanation for how things happen. In order to be a theory, it has to be something which has never been demonstrated to be false, proven false, never falsified, and it has to be something which is widely accepted. You might hear me say this many, many times. You will hear me say this many, many times. The consensus of experts always outweighs the opinion of any one individual expert. So the last step for something becoming a theory is it has to meet that criteria. It has to have a consensus of all the experts involved in that field who support it. Stay tuned for the next section. We will be covering the history of geology as a science. See you then.